Hello there and welcome to this presentation. A little bit about Repertoire. So Repertoire is a startup that primarily revolves around Kubernetes. We have strong Kubernetes expertise in provisioning, in tooling, in consulting and developing solutions around and inside Kubernetes. So we basically position ourselves as a Kubernetes pro DevSecOps company. And we help startups, enterprises, and solution providers with full capability in setting up and developing solutions around Kubernetes. We can help you in all aspects of Kubernetes, right from provisioning on various cloud providers, on-premise, bare metal, to setting up the internal tools, technology, and components of Kubernetes, to actually setting up the frameworks, the programming languages, and to also giving access to your admin and user and even IoT devices, giving full security, security hardening, and performance all along the way. So we are you can say a full stack Kubernetes solutions company, and that's our strength. So this is a little story of why we built fsKube in the first place. So we were doing a lot of consulting work for many of our customers on Kubernetes, and we found that setting up of Kubernetes is very, very cumbersome, very challenging, and it is not consistent across different landscape for different projects. Also, we were struggling to monitor infrastructure cost when we used to provision Kubernetes cluster for either POC or demoing or even for production use. And setting up of DevSecOps after provisioning of Kubernetes was also very tiring and cumbersome. And then we needed in case of production Kubernetes, we needed a dev QA production workflow. So people can continuously do CI/CD in dev, but you have a workflow which promotes your builds to QA and then promotes that to production, and does a rollback in case there's a production error. So all of these things were not available, and we searched everywhere, but we couldn't find a use case or a tool that had all of these encompassing needs. So that's the genesis of fsKube. So we searched around quite a bit actually, and we couldn't find a single tool that could, be repeatable, reproducible, could boost our productivity. Shouldn't have any lock-in. It should be a desktop application. We stressed on that because we didn't want our secrets and tokens to fly all over the place on the internet. And it should provision a complete full stack Kubernetes, not just bare metal or bare bones Kubernetes, but a full stack Kubernetes where we could be productive from the get-go. So that was our goal and since we couldn't find a tool, we thought of building one. And this tool became very, very successful inside the company, and then we thought of releasing this tool to the wider audience. So let's do a quick demo of fsKube. This is not going to cover all the aspects of fsKube. fsKube is a very deep tool because it covers a wide gamut of functionality, but we're going to stress on the most important functionality that we have in fsKube. So let's dive right into it. All right, so fsKube is, as you know, is a desktop web application, and we built it purposefully as a desktop web application so that our secrets and tokens do not go over the internet. It's safe and sound within our desktop and with us. So when you download fsKube, this is what you're gonna get. It's a single executable binary. You don't need to install any dependencies. It has everything in it that you need, and when you click on it, it will start the fsKube server. So you can actually start it on a desktop, or you can provision a Windows virtual machine up in your cloud, and you can start and access it from there. Currently fsKube is built only for Windows, but we will be releasing fsKube very soon for Linux and Mac. So this is you're gonna get a splash screen on your console which says that fsKube is ready, and you're gonna get host and port where you can access fsKube. So this is the host and port. It runs on 5678 port. Open your browser, go to the port and host, and you're gonna see you'll be greeted by this screen if everything has already been configured. Otherwise you need to go to the configuration screen. This is a global configuration screen where you need to put your AWS access key, your AWS secret access key, and the default region and default output you can let it be. Those are the defaults set by AWS itself. You also need a GitHub personal access token for DevSecOps, and you need an fsKube license key. So all the links are in there which will help you in creating these access keys. It's very easy to follow. You just have to create a user, IAM user with programmatic access in AWS, and if you follow the documentation it is pretty easy. Similarly with GitHub personal token, access creation is also very easy. So once you have put in all these parameters in the global configuration, then you can go to the dashboard. The dashboard will start working and it will show you the cost breakdown of all the previous month, the current month, the increase in cost compared to the previous month, the number of services used, and the breakdown of the cost per services that you're using. So this is a very good functionality where we can see which resources are consuming most of the cost, and we can take corrective actions. So we have reduced quite a bit of our bill, as you can see, using this functionality, and we will be enhancing this functionality in the coming versions of fsKube so that you get a more granular cost from AWS, and you can actually drill down and see exactly in which region, what is the cost, what components, what resources are using most of the cost in your cluster. So but to begin with, this is a pretty good functionality. And now let's get into setting up a cluster. So to set up a cluster, which is a step one, you have a couple of modes like quick create, full create. In quick create you can create an experimental cluster, but we're gonna use a full create mode. So in full create you're gonna get all the geographic regions that AWS currently supports. If it adds a new region, you're gonna get a new region here. Let's select a region, US East 2. So it's gonna fetch all the availability zones for our specified instance size, which is M5 large. So these three are the filtered availability zones that can host our M5 large instance at this point of time. You need at least two. We got three. So this is one of the good functionality that improves the user experience in creating a cluster. We're going to keep the managed node group yes. We're going to put a name, and now we're going to create a cluster. The cluster creation takes around 15 to 20 minutes because it checks all the parameters, it sets up VPC, networking, and all other things. So so it takes around a bit of time, and you'll see the screen flashing for some time, so don't worry, it's still working in the background. The good thing about fsKube is that if something goes wrong while cluster creation, it won't go wrong, but if something goes wrong, it deletes the cluster and all its resources and tells you that cluster has been deleted. So as you can see, the cluster has been created, and we can then go to the manage screen to actually see the cluster. We can destroy the cluster if we want to. So it has been created 53 minutes ago. And we can even refresh the config. So this helps us in getting the config file for the cluster, where you can issue your kubectl commands if you wanted to. At any point of time you want to refresh, you can refresh the configuration of the cluster. So this was a quick demo of the cluster creation. You can see other demos as well on our YouTube channel. So as you can see, the cluster has been created, and the name of the cluster is test. It is 1.17, the Kubernetes version. And you can see the compute nodes in the cluster. You have the node group, which has 3 nodes in it currently, and you get all the information. So you can also see all the information about your cluster in the AWS EKS console. The instance is M5 large, disk 80 gigs, and you can drill down into further information as how this. So this is a very standard cluster that we have created on the AWS. Now in this, what we're going to do now, that when our cluster has been created, we're going to go to step 2 and install and set up all the necessary components. So we have ingress, you have service mesh, you have backup and restore. Basically we can take backup and restore a full cluster and recreate all your production data exactly as it was. We can enable monitoring and logging for all your applications and pods and containers and Kubernetes itself. Metric servers for all the metrics to get all the information, and the dashboard, which is a standard Kubernetes dashboard. So all of these components, all pre-configured, tested, ready to be installed. And once you click install, it will install the cluster components, and you can then access the components very easily. So here we're going to access all the components that we just installed. This is Linkerd. This is a service mesh. It's one of the best service mesh on Kubernetes. It takes consumes very little memory and CPU, but gives a lot of functionality. We are a big fan of Linkerd, and you can see based on your existing namespace, you can get all the service mesh metrics. And then you can, for example, if you enable it for a specific namespace, you can get a Grafana dashboard giving you all the details of the network requests, the request volumes going in, and all the parameters, the latency, the success rate. So it gives you a nice view into your applications. And you can monitor this and see where your latencies are, and then you can fix those in dev and test it on QA and then move it to production. So it gives you a very deep insight, but it just doesn't stop at there. There are other components to Linkerd which are very, very useful. We're going to talk about those in the upcoming slides and talks. Another component is the Kubernetes dashboard. Gives you all the CPU usage, memory of the pods, containers working in a namespace. It's pretty detailed, and your team can have access to it instantly. This is all pre-configured to work with AWS EKS, so you don't have to do anything in terms of understanding how to set it up, how to access it. So Kubernetes dashboard is already set up for you, and you can go to various parameters and see how your Kubernetes is working. Another thing is the monitoring and logging. So we set up ELK for you. So there are some tweaks that we apply to optimize ELK for AWS EKS, and as you can see, the ELK stack provides a range of functionality, but most importantly, you can build dashboards. And this is one of the sample dashboard of an e-commerce, and you can look at nice real-time charts on various parameters in your e-commerce. So it's a very powerful tool that you can use to not only monitor and do logging, but also create nice reporting dashboards for your business and query those dashboards on a regular basis to improve your business. So it's one of the most influential tool in the Kubernetes ecosystem, and you can create reports which are very different than your traditional reports, such as this is a very graphical report that you can actually email it to your executives to understand the segmentation of product sales better. So these are some of the functionality you get out of box with fsKube. You don't have to read a lot of blogs, documentation, or anything. It's just out of box, just one click, and you get all of this ready to go. These are all been pre-tested to work with AWS EKS with a very deep integration with their GP2 volume types, etc. So you don't have to so to speak, break your head around how to get things working. You'll be productive from get-go. And these are some of the charts and graphs that you can build. It's pretty powerful, actually. This is in step 3. We're going to set up a framework. So we have Django, Spring Boot, and Rails coming up along with Node.js. So we're going to select the cluster we created. And if we have the GitHub personal access token configured, then we can just create a new app. What's this going to do is it's going to create an application template in your GitHub repository, which will link to fsKube, but also to your AWS. So all three will create a triangle. So now this is creating an application template in your GitHub repository called my app, with all the parameters related to Kubernetes. And as you can see, it has created a project in your template, but it has also created and linked your AWS container services. It has created a registry in your AWS account automatically where you'll host all your containers. And if you go to your GitHub profile repository, you can see the new application being created automatically for you, and you have 2 branches, feature for development, master for deployment, and it has already been integrated with your Amazon AWS. So you have a you have a nice integration where your fsKube, your GitHub, and your AWS are now tightly integrated, and this creates a seamless experience for your developers. In case of DevSecOps, they don't have to worry about setting up various DevSecOps tools to push a CI/CD pipeline into into your Kubernetes cluster. Everything is done for you, and your developers are ready to get go from the moment the repository has been created. All right then. So now that our application has been deployed into the Kubernetes cluster, we're going to start monitoring the cluster itself. So we're going to see how the cluster is doing in terms of the number of nodes it has, and each node, what is the CPU memory consumption, and what are the namespaces inside these nodes, and what are the workloads happening inside these namespaces. So it gives you the whole in a single page. It gives you the entire profile of your Kubernetes clusters, and you can see the pressure, the memory pressure, disk pressure, PID pressure, and the readiness probe already in green. If it is not, then it will come as red, and it will send out an email to you saying that this has failed or it's not initialized properly. So this is very, very beneficial for operations team to know exactly if there's something wrong with the cluster or something is failing. And this helps the operation teams to actually take corrective actions on time. So this is one of the key features of fsKube. So let's talk about release management, which is a very important feature of fsKube. You can, now that your fsKube, your GitHub, and AWS has been integrated, you can start releasing your source code via CI/CD. So you can create a CI/CD time cycle of 5 minutes or more, and every 5 minutes it will check if there is a change in your feature branch in GitHub, and it will release that automatically to your cluster. So we just set up a 5 minutes window, and what is going to happen now is that fsKube will automatically create a a development namespace for you if, as and when your developers make changes in your GitHub source code. So imagine a developer now going into the feature branch and going to a file within your project and creating a change in that project. So suppose I go to the source project application. Let's go to the view.py, and we're gonna make a change in view.py. So we're gonna change maybe the name from Aaron Carter to, let's say, Aaron Sean. So imagine a developer making a change in the source code, committing the source code, and this is gonna trigger a series of events. As everything is integrated by fsKube, it's gonna trigger a series of events or workflows, and automatically your application container is gonna get built and gonna get registered in your Amazon ECR, and automatically that particular container is going to get deployed in your Kubernetes cluster. So all of this automation from the get-go, there's nothing to be configured or done by you, your developers, or operation team. So this is one of the benefits of fsKube, and it's fully automated, fully ready to be used, consumed by your products and development team. As you can see, this is now building, tagging, and pushing the container image to ECR. So all the steps are being done, and it's going to finish in any moment now. The container image is very small. We have also ensured that the image is very, very small, and we use a very secure image. And now we're going to jump to the ECR to show you the container we just built. So there's no container. We refresh, and as you can see, there's a new container with the tag of the build hashtag from GitHub, and it's 83 MB in size. So this now will automatically get deployed to your Kubernetes cluster. You don't have to do anything. We're gonna just refresh the monitoring page, and you're gonna see a new namespace appear called development. And so fsKube automates all of your dev QA production lifecycle for you. So there is very little that you have to do in terms of getting the automation working around Kubernetes. So now we're going to see the development namespace here, as you can see, and once you click on it, you're going to see all the pods deployed and all the CPM parameters and all the other parameters, readiness parameters shown up. So you can see the application my app being deployed and the Postgres database being deployed in the development namespace. So fsKube automatically created this namespace for you. And if you go to the load balancers, you can see that the load balancers for accessing your application has already been created. Just copy the DNS name and hit it on your browser. If your application port is 8000, which is the default for a Django application, then you're gonna hit on 8000, and here's your application from a development namespace running in your Kubernetes cluster. So you don't have to set up anything to get this up and running in development namespace. All right, so development is done. So now what about QA? How do you get the project into QA? So you're going to cut a release from the master branch, and you're going to version it, using semantic versioning. So once you have pull and merged all your changes from feature to master and did a release, fsKube is gonna again trigger a workflow, and this time the container creation process is gonna be a bit different. What's gonna do is it's gonna create a container but with a tag name corresponding to your GitHub release version. And that's going to appear in your quality section. So now it is v1.101, and then you can deploy to the testing namespace for QA. So as you can see, everything is integrated and there's nothing that you have to do manually to trigger these actions. So once you deployed to QA, we're going to see how that works in the QA namespace of the cluster. So for quality, let's do something different. So what we're going to do is we're going to go into quality in the feature branch, and we're going to make a deliberate mistake by a developer. So imagine a developer doing a mistake, and then that mistake is like multiply by 100 has been removed in the dashboard, and that mistake is being pull merged into your master branch. So from dev, the mistake is coming into your master branch, and what we're going to do is we're going to cut a release out of this. So as you can see, the same mistake is now here. So the multiplication by 100 is gone in the dashboard. So once we cut a release for this particular mistake, let's give it 1/2 new calculations, and we're going to release it. It's going to land up in our QA section after it builds the container. So it's building the container. You refresh the ECR and you can see the new image v102 here. And now we're going to deploy it into our test. So once we refresh the test cluster, we see v102. We deploy it into test with the mistake that we made, the developer made in the feature branch. So it's going to take a while, but as we get it deployed, we're going to see that 60% was, and after mistake, it's going to turn into 0.6%. So there is a mistake, and this is unfortunate. The developer made it, and now what has happened is that let's propagate this mistake to production. So unfortunately, the QA also approves it for production. It lands in the production section. We wanted to deploy it into production. So now we're going to deploy the same thing into production. And this is QA and this is production. And as you can see, 60% is the conversion. Production, let's refresh the screen now, and the mistake will appear 0.6%. Now you don't want, when you arrive at such a situation in production, you quickly want to roll back to your best working version. So in fsKube, we have a very nice functionality, rollback to your previous working release. So now we're going to do a rollback, and what this will happen, this is dev, this is QA, the mistakes are there. In production, the mistake is there, but when we refresh, the mistake is gone. So now you're rolled back to the previous working version, and this is one of the biggest features of fsKube for the release management. In the operations, let's have a look. So operations, as of now, we can see the minimum, max, and the actual number of nodes in the Kubernetes cluster. Let's go to EKS and see whether we can see the number of nodes in the compute section. We see the 3 is the desired size currently. What we're gonna do is we're gonna increase the number of nodes from 3 to 4. So let's go back to the fsKube, and from 3 we're going to change it to 4. We're going to apply the change, and in very short duration of time, what's going to do is it's going to bump your number of nodes from 3 to 4. So We're going to go back to the EKS cluster, and we're going to go back to compute, and we see that the desired size now is 4. So you can actually increase, decrease the size of the cluster based on your requirement. We're going to automate this in the upcoming releases to Spot instances and Graviton instances. So this was a very short demo of fsKube. If you have any questions, queries, or inquiries, then contact us at hello@repertoire.com. You can visit our site. It's www.repertoire.com, and you can also visit us on LinkedIn. Please do check out fsKube. Let us know your feedback, and let us know what you think of it. If you need any improvements, if you see there are some gaps, do let us know, and we'll be happy to accommodate and talk to you. If you need any demo, so let us know on this email address, and we'll be reaching out to you for scheduling a demo specifically for you and your use case. Thank you very much.